Okay, so I've got my Revit file set up for rendering in a very basic way, but it is set up. And now I'm going to go through the steps for linking this to 3ds Max again, just so that you don't have to look at the old, the last video I did on materials, just to get these steps. But before I take it into 3ds Max, I just want to remind you about something that you always need to consider when you're rendering, but particularly when you're going from Revit to 3ds Max, you really need to have a good understanding of exposure values. So I've just brought up a Wikipedia page, or not Wikipedia, whatever the first one is that comes up about exposure settings. They'll all have the same information. The Wikipedia one, I'm sure, would have all of these things because they're standard. And what I'm looking for is exposure value settings. And here it's telling you how to calculate them using the ISO, which is the film speed, and the shutter speed and the aperture. Those three things go together to make your exposure value, but I'm not going to bore you with all of those calculations because all I want to see is the actual EV values. So in fact I will thought that chart would have been there, but let's just get the Wikipedia page. Because I'm not at uni and I can use Wikipedia here, which is nice. So yeah, so these are the exposure values, which again, if you've seen f-stops on cameras, you can translate them to those f values. But I'm going to look at the EVs over here on the left. So EVs, again, are exposure values. And by combining those three settings that can affect the brightness or the amount of light that your film receives, you can, of course, get the right lighting levels for your renders and photographs and anything else that these apply to. And the reason I'm showing you this is because you do need to have a basic idea of the ranges that you work with most commonly. And so I've just highlighted those. So I've actually gone too high. So these are the ranges. So most commonly, when you're working with either photography or 3D renders, the range will be from 2 to 15. So the way to think of exposure values is that it's an exposure control. So that means the higher the value, the more control you have over light. And in other words, the more you're limiting the amount of light that reaches the camera. And so, or the film. So 15 is again usually about the highest. And so that would be used for outdoor photography on a bright sunny day. So we want the most control of sunlight, or of light, because we've got a lot of light that's going to make things really bright. So by setting the setting to 15, again, we're going to limit the amount of light which is going to control all of that bright sunlight in an interior that's rendered with minimal artificial lights. You might only need a value of 2. You'll very rarely go below 2 because that's for really low level lighting, 1 and 0. Okay, so looking into Revit, you all would have seen these values, but you might not have realised what the numbers meant. So again, just bringing up the render dialog box in Revit, if we go to adjust exposure, then you can see up here the exposure value that's set there for this render that is for these artificial lights that I've got in here, set to artificial only. So I've got a fairly low value because I don't have very many lights. So I'll just stop that there. And then, again, going back to adjust exposure, so if I take it down to 2, again, that's not going to be enough control, so it's going to be very bright. If I bring it up to 15, that's going to be too much control and I can barely see anything. But for sunlight, that would be perfect. So again, between 2 to 15, and for renders that don't have sun, you're generally going to be below 10. So even at 10 in this one, it's too high. So down to 8, and I can start to see some detail coming in, surfaces that receive light, and then coming down further, we get the value that we want. Okay, so when I transfer that into 3ds Max, I need to have some idea about those settings. I'm going to go to the File menu and then Export FBX. And I'll choose where I want this file to go. So I'll make a new folder because I'm doing this for the second time. Normally we'd just use the one I've done previously. And so notice the file name has the view name in it as well. So 3D View 1, I haven't renamed it yet, so that's the name of my view. You'll see why that's relevant in a minute. Okay, so now into 3ds Max. I've got a blank file already open. But if you're not sure whether you've made any changes, you can always go to the File menu and then Reset. And here, Don't Save, and then Yes. And that will put all the settings back to default. And so then to import that Revit file, I'll go to the File menu and then Import and then Link FBX. I know it's tempting to use Link Revit, but trust me, it doesn't work as well as Link FBX. And they're both links. So you can update and bring in changes that you've made in Revit, and because it's linked, have that update in your 3ds Max file. So Link FBX, and then I'm going to go and find that file that I've just saved in my new folder there. Choose it, open, and you don't normally need to change any options here, but you can look at this preset option and either set it to by category or family type. And actually, if you're not sure, maybe combined by family type is a good option to start with a project of this size. It's not very big, in other words. So that's good. But I'll just give you a tip there. If you've got a larger file, maybe combined by family type can make things a bit too complicated. So that's it. The one setting there to look at under presets, and then you can click attach this file. And we've brought the Revit model into 3ds Max. And notice how the whole model has come in, not just what we could see in the camera. So that's a really important idea, because you should use a camera to export your file, like I've got there. That 3D View 1 is a camera view. So I've used that to export my FBX file, but it's really important that you realise it is still bringing the model in. But I also want to use that camera to start setting up my render. So do you remember the shortcut to set the camera view to the viewport? So easy one to remember, C for camera. So C on the keyboard will set the camera view to the one you've brought in from Revit. Okay, so I'm going to go straight to rendering. And if you're not sure, that's always a good thing to try, just to see how it's working. So you can see there, obviously, it's not rendering the same way as it was in Revit. Okay, so Revit, it looked very different because we had the artificial lights rendering and no sunlight. So there's one setting I showed you last time that you might remember that will make it better. Again, it's under rendering, and then environment. And then you've got that use map option. So I won't explain it. If you want to understand that one, go back to the previous video and I'll explain all of that. But here I'm just going to turn use map off. And then I'll press that render button again. And you're going to see then, it's actually pretty close to what I had in Revit already. So it's brought in a lot of the settings that Revit had, but I'm still going to check my exposure. Now, I'll show you one other thing as well. So when this is finished, stop that. Okay, so if you see that when you've done that, or turned that environment map off, if you still see, or if you think there's sunlight coming in and ruining your render, I just want to show you how to adjust that. Maybe so you don't have to go and find it in the view. If you go to the Tools menu and then Light Lister, you've then got all of the lights in your file in one list, and then you can just make sure that the sun and the sky are both turned off. Right, now mine are, because when I exported from Revit, I had that camera view set to artificial only. So if you've already set that in your render, and that's why it's a really good idea to do some of the setup for your rendering in Revit first, even if you're planning on doing the final render in 3ds Max, because again those render settings do come across from Revit to 3ds Max. But again, I don't need to change those because the settings have come across the way I want them to, and the sun and the sky are off. So then it's probably not bright enough though, and so that can, instead of being controlled by the lights, so if I again go back to the light lister, there are my downlights, and I could adjust the brightness and it would make the whole render brighter. But I don't want to do that because I don't want to change the brightness of the lights. They're actually the right brightness. So instead I'm going to go again to rendering and then exposure control, and you can see there's my exposure value. So notice it's slightly different to what I had in Revit. So in Revit it was 4.72. So I'll just make it the same, roughly 4.7. Sorry, and now I'll just render again, and we should have finally the same brightness level as I had in Revit. There we are. So you've got a few things there, but primarily when you're looking at lighting levels, as well as the brightness of your lights, which often shouldn't be adjusted, you've got the exposure value. So if you see these messages, don't worry too much. That message about the camera flip plane isn't actually that important. You can solve it coming up anyway, but again, don't worry too much about that. Okay, so that's the main idea. So again, before you can really understand lighting, you've got to be comfortable working with exposure values. And then coming back to look at the lights in Revit, now I've shown you in lighting families before how you can adjust the light emitter shape. So maybe I'll just show you. So if you select a light in Revit, they're all families. So you'll always get the option to click Edit Family. And then you're going to see some of the things that are hidden in a project file. Mainly the emitter shape. So this thing here, that yellow thing, is the emitter, the thing that emits the light. And this one is actually the hardest to understand because it's what's called a web distribution. And I don't want to show you that one. So with the light selected, the yellow thing, that again is our, well, in Revit it's called the light source definition. But I always think of it as the emitter, the thing that emits the light. When you click on that that yellow object, you'll get that option to click, change the light source definition. So you've got two basic options there. You've got the emit from shape, and then you've got the light distribution. So the one at the top, that's fairly easy to understand. It can be from a point, or a line, or a rectangle, or a circle. So that's the shape that the light comes from. Now, it does work in Revit to a degree, but if you've ever tried, shown about Leslie, because I know she was trying this, if you ever tried to render, say, a fluoro tube or any sort of linear light and get the light coming from that whole length of the light fixture, have you ever had trouble doing that? Well, yeah. Yeah, you would have seen it. And exactly. That's the trick. That's the trick. Yeah, it will go in spots. So that's exactly right what you're saying. So the problem with Revit is that it's got these emit from shape options, but notice how as I change them, the light is still basically coming from that point in the middle. So it's not perfect. And again, it's one of the limitations of rendering with Revit. So even though you've got those options, again, because they're not perfect, I'll show you in 3ds Max how you can make them work better. But that thing Rebecca was saying of copying the lights and having many lights along that linear path will give you a pretty similar effect. The problem with that is that the more lights you have for rendering, the slower the renders are going to go. And it's one of the main things that affects the rendering speed. And so if you've got a scene with a couple of hundred lights, which is often what you'll need to get that nice sort of distributed effect, the renders are going to go really slow. And also, it's probably not going to look as good as the other one I'm going to show you in a minute. So, again, it's good to know you've got these options, but that trick Rebecca just mentioned is pretty good. So, if you don't want to render with 3ds Max, you could have, again, many small lights next to each other in a line to get the effect of a linear light. But that's just the emit from. Then you've got what the light does once it comes out from that shape. And it can either go evenly in every direction, which is sometimes called omnidirectional, but in Revit it's called spherical. In other words, the light goes in all directions. You can also have hemispherical, so it goes in all directions in a 180-degree distribution, or explaining it badly, but half a sphere, essentially. So it doesn't go, if it's going down, it won't go up. So those two can be pretty useful. And so if you've worked with, say, the studio light, so what sort of distribution do you think the studio light, to get the standard light that you might have used just to add light to your scenes without having a light fixture, this studio light? Oops. So I'll just place one in there. So what sort of distribution do you think that might have? Do you think it's going to go down or up or spherical? Yeah, spherical, definitely, yeah. Okay, so it's lighting evenly in all directions. Now, technically it's not. I don't want to bore you too much with the technical things, but it's actually set to web, this one, but it is pretty much spherical. And the old one, this is just the new version of it. They've tried to be a bit too technical, I think, with the new versions of Revit. So they've changed it to the web one, which I'll get to at the end. But I'm going to load it back in with the spherical option. And so then when I render now, you'll see we'll get light in all directions. I should take this stock medium. But I'll just get it going. There we are. So it's sliding up and down because it's spherical. So if I change it to hemisphere, okay, so then it's just going to go down and we won't see that big pool of light on the ceiling. Which can in itself be a really good thing, because often when you use studio lights, that's the problem, that you'll get too much light on ceilings and things like that where you don't want the extra light. You'll often just want the light to be going down and lighting things up that are on the floor, or furniture and other things that are below that light. So that's, they're the two basic distributions. But then there's another one that you use probably more than those even, and that's spot. So again, omni and also spherical and hemispherical are similar. They're fairly even. But then spotlight gives you a couple of extra things. So instead of just having an even distribution, you've got this cone, which lets you target the light. So it's directional, in other words. So here you can see it's actually tilted, and I don't want to go too much into that. So, but if you are trying to work with the spotlight, you'll see that's often how it would come up at first. So to set the tilt value, I just need to go here to family types. So if you've been working in families, hopefully you remember that one. Family types here gives you lots of the important settings for any family. And you'll see that spotlights have a built-in parameter for the tilt angle. And I'm just going to set that to 90, which is what I think it should start on anyway. I don't know why they've got it on 60 to start, but that's just how it is. So when it's on 90, now the spotlight points down, and we can see it a bit more clearly. You've got that inner cone, which is the brightest part of the light, and then you've got the outer cone, which at the edge is where it reaches 0. So the light goes from, again, maximum brightness there to nothing. So we're going to get a nice spread of light across that area. So I'll load this one back in, and then we should be able to see that. I'm just going to change my floor over to a left reflective one, just so that it's easier to see. Yep. Yes. Oh, yes, yeah, I should have made that clear, yes. Exactly, that's right, yep, that's it. And you can make any light do that, but the studio lights are set up, automatically to not show, Yep. So you can see there the bright part of the light in the middle, and then it fades out around the edge. So I can go back and change it in the family, but I'm actually just going to do it by selecting the light here, and then going to Edit Type. So if it's not clear already, that Family Types button that you have in a family file pretty much gives you the same settings as you have when you click Edit Type with that family in a project file. So when I scroll down, you'll see it's got that same tilt setting, but then it's also got these other two, spot angle and beam angle. So the spot angle, or the spot beam angle, sorry, I'm using terms from another program. So the spot beam angle is the inner part, the brighter part. So I'll make that 10. Oh no, so I'll make it 20. And then the beam angle, so the field angle, is where it reaches 0. So I'll make that 20 as well. So they're the same. And so now when I render, we're not going to get a soft edge to the light, we're going to get a hard edge, because there's no transition. So it goes from maximum brightness to nothing. And, well, it's a bit soft, but see, it's basically a harder edge than before. I'm going to go back and I'll make that a smaller angle. So you can see that it's working. So I'll make it 10 and 10. Okay, so you can see there that's controlling that spotlight area. So now, if I just bring that field angle up, so I'll make that 100. So now, I should get a softer edge. This has actually become a bit harder to control with the new rendering software. It's changed the physics a little bit. So probably won't be as clear as when I show you in a minute in Max. Here you can see there it's not really obvious that there's a change, but there is. Yeah. But to really see the effect, I know because I've played around with this a lot, I've got to bring that that beam angle right down. So I'll try making that, say, 3 or something. Again, it's hard to really control this in Revit. It's also a very bright light, so I probably need to reduce the brightness as well to see the effect. But what I'm going to do is just switch over to 3ds Max and show you there, because they're the same lights, but you've got a bit more control in Max, and also you can see it in real time, so I don't need to keep rendering just to show you these lighting effects. And so what am I doing? Yes, sure. Oh. Oh yeah, no, I'm just saying you can do that with any light.
Oh.
Yeah, yeah. But yeah, normally you're right, you would do it with a down light. So, well, I was actually about to make a new light, but I'll just show you. So the lights that I've brought in from Revit can actually be adjusted in the same way. So I'll just do one of those. So here I've got my lights. You can see, I might just go to wireframe so they're a bit clearer. And okay, so there's one of the lights that came in from Revit. So over here you'll see you've got all the same options. It's just that there's a lot more settings to wade through, but it does have all the same basic options. So this is, again, that's what's called a free light. So again, it was a downlight basically, but it's got this web distribution, which I'm going to explain last. So spotlight is what I've been showing you. And so now, notice how you can see the cone in the viewport, and there's the beam and the field angle. So if I adjust those things, you can see straight away the effect. And if I go and set the shading and then set it to high quality and then make sure it's got the lighting, yeah, in the viewport, that's it. So it just might take a second, but it should show us the lights. I think it's a bit too much for this computer, so what I'm going to do is just make it have the one light. So I'll just turn up my other lights off. And so now we can just see the one light. Still a bit too much for it. Okay, these graphics cards should cope with this. Oh, I was trying to do the ambient occlusion. Okay, so I'll just fix that. And we've got to make sure the exposure value is set here as well. No, it's not working, but you can get the lights to show in real time. It's just that when you bring things in from Revit, it's a bit intense on the hardware. So I'm going to render it, and then we should see just that light. There we are. So you can see it there. Actually, I can't get it to show in real time because that's what I really want to show you. Okay, so you can see there's my light, and what I might do actually is just save this and switch over to another file. So let's just get this. Okay, so I'm just going to make a blank new file. And just make a couple of simpler objects, just so we can see the lights without having to render. Okay, so I've just made a just box there, and just going to make it a bit bigger, so I get a bit more room. Yep. And then I'll put a light in there, so free light. Move it up off the ground and set my display. There we are. That's normally something you can do without that much trouble in 3ds Max, but again, things that come from Revit sometimes have a bit too much other stuff going on, and it overloads the hardware, and these poor old computers, even though they were good when we bought them, probably a little bit past it for this sort of work. So, so now if I look at that light and find the same settings, so I'll get the spotlight distribution, and now here we go. So then you can really clearly see the hotspot and beam working together. So again, when they're close, when those two settings are similar, you're going to get a hard edge on the light, and then when you bring the field angle out and make that different to the beam angle, you're going to get a softer edge to the light. So again, so that's something you've always had in Revit, the ability to adjust that setting. It's just harder to see it in real time. Believe it or not, you can see it in real time in Revit as well, but I'm not going to show you that because it will probably kill the hardware here, but you can. Normally though, you need to render to see it. In 3ds Max, as you can see, it's often the case that you do have to render to see it as well, but there is usually more chance of being able to see it in real time, like I'm showing you there. So real time, it just means in the viewport as you work, you can see those effects. And so they're the distributions you need to understand. So I'll get to the lighting levels in a minute, which we haven't looked at yet, but the lighting levels is the other major thing. But you'll see, again, with those basic distributions, so again, just to remind you, spherical, hemispherical, and spot. You then have associated settings. For the first two, for spherical and hemispherical, you don't have as many. So looking in here, you can see we only really have the intensity, which is the brightness and the colour, which I'll come back to. But for spotlights, you've got those extra settings, mostly to do with those angles. So again, with spot, back in family types, you're going to have that tilt angle, but then more importantly, the spot and the beam angle. So the beam and the field angle. And then the last one I'll just show you, which again, you probably don't need to know all the ins and outs of, but you need to know that it's a thing that people do use a fair bit these days in rendering software, Photometric Web. So it's called, sometimes just called web distribution. I don't know where the word web has come from, but essentially it means it's the most physically accurate distribution, and you can't set it yourself. You need to get a what's called an IES file. It's the Illumination Engineering Society. I'm pretty sure it's the one in America, but it might be a worldwide thing. And so those Illumination engineers make files called IES files, and you can search for these files. And I'll just close this, and I'm not going to save changes. So if I go back to that light, I'll just go and delete it and load it in again. Why is it loading? Oh yeah, there we are. Oh no, I didn't load it, did I? So I'll do that one more time. So I'm going to load family and load that studio lighting again, so it comes back with the initial settings. And there we are. So you might have remembered that when I first started looking in that file, it had this photometric web distribution. So, like I said, it's the most complex, it's the most realistic though, but you can't really set it. Because again, all the settings come from this IES file, and it's set over here. You can set them yourself. You can import those files and say, here you can see it's got this photometric web file, and when I go into the family types, you'll see the name of the file. There you can see it's whatever, SL1MH, whatever that is. And of course, we're not Illumination engineers, so we don't need to know how to make those things. But you get a great selection of them with Revit. Right, so these are all files that those engineers have created that give you the accurate distribution. And if you're interested in how light works, you might get a big shock when you realise how light really works. It's not this straight line thing that you think it is when you do basic physics. It's a really, really complicated thing that, again, isn't, I don't think it's intuitive. It's quite unnatural when you think about the way it really does work. So let's just see if we can get, these are my scene assets. I'm just going to get them from Revit. So I know we've got some with Max, but I don't want to go and find those. I'm just going to grab one of these. Yeah, that'll do. So there's my IES file. So now it's got this distribution that is much more realistic. And let's just render to see if we can get a bit more detail there. Yeah. So you might be thinking, well, that's not much more than what you get with a spotlight or even like a hemisphere or something. So maybe I'll find one that's a bit more interesting. So I don't know what most of these names mean, and I'll just grab one at random. Yeah, there we are. So that's different. It's not as good as what I was hoping for, but it'll do. So it's got a different distribution. Probably a bit hard to see with that brightness. I'll just reduce that. Oh, what's this? It's so yeah, it might be a bit hard to pick it up with these. Unfortunately, I'm not finding the ones that have the really noticeable, unusual distributions. But you can maybe see there, it's not just a circle of light. And you'll be amazed when you look closely at how light really is distributed. So even from these fluorescent lights in here, it's not just an even straight line. It moves in these really strange ways depending on the light fitting and the type of light that you're using. So that's all I'll say about it for now. But if you're interested, look up light distributions, have a look on that Illumination Engineers website, and you'll be able to read all these things. But again, as long as you know that distributions can be a bit unusual, but when you put the nice distributions that these engineers make for you, you get these really beautiful, realistic looking lighting effects. And so more and more now with Revit even, not even worrying about 3ds Max, even just in Revit, you'll see a lot of the newer lights. So this one here that I brought in from the new library, that just LED light, if you look at that one, I guarantee you it will be, yeah, there we are, another photometric one. In other words, another web distribution. So again here, when you select it and look here and you see that web one, it means it's using a file they've decided is good. And here's that file, or that's where you can see that it's set, and in family types you can see the name of the file really easily. So maybe I'll just, to finish off that, do a quick search and see how easy it is to find them. It used to be really easy. And they're free, so you don't have to pay for these things. So let's just search for IES file. There we go. Okay, so you can download all of those, and again, explains a bit about it there as well. And maybe if we go back, and we might even be able to see some better distributions, just so you can get an idea how. There we go, that's a good one. Okay, so see how here, it's not just straight lines, and it's even, so it's not even. So the unevenness is, I suppose, what gives you the effect of different kinds of lights. So there's some really different, example of different distributions. But again, you don't need to be the engineers working those things out. Just find the files, and you can get some beautiful, amazing, realistic-looking renders, or even just stylized renders, simply by choosing different web distributions. So going back then to the other main things that affect your lighting. So again, mostly been looking at distribution, but then you've got probably the things that you would naturally think about with lights, with brightness being probably the main one. So whenever you select any light, family in Revit, and go to edit type, if it's been set up for rendering, and not all of them have been, but if it is working for rendering, then you set the brightness using this initial intensity. So don't use light loss factor. I see a lot of people using that, and they click on it and think, great, there's a dimmer, so I can use that to make it brighter or darker because it says dimmer or brighter. Great. Don't use it. It's not what you think it is. It's better than it used to be. It used to be something I just said never use. But you can actually use it sometimes for certain things these days, but it's again probably best to be avoided at first. And especially if you go to the advanced, you'll see it gets really involved. And you shouldn't have to touch that because it's not really changing the base level of brightness. It does something different. I won't go into the physics, but again, avoid that one. Even though I know it's tempting. The one you want is initial intensity. And then you can see you've got these different ways of setting the brightness. Again, it's all to do with the physics. So if you're the person who buys the light bulb in your family, you would probably know a little bit about this. When you're looking at the brightness of the new, more efficient light globes that you can buy, which is pretty much everything these days, so all those efficient ones. Do you remember how they give you the brightness? Do they do it in watts? Yeah, so when you're looking at buying a light bulb, do you look at the watts or something else? Sorry? The what? Oh yeah, you can. Yeah, if you know how to do that, you can. You can look at those two things together. So that's the power consumption and the efficiency. The lumens, that's right. So they all have the lumens on them these days because the wattage or the amps or whatever you're looking at for power, it needs to be combined with the efficiency. Right, so how much power it uses. And until you know those two values, you won't know how bright your light is. Right, but then, let's just cancel this. Okay, so again, wattage isn't a really good way of setting or knowing what the brightness is. Let's just go to there. But flux is, I don't know why, yeah, there we go. So luminous, flux, you can see there's just that one value, which is lumens. So use that instead to set the brightness, and it'll be much easier. And it'll also give you a better understanding of lighting. And with some of you asking me why lighting isn't in the course anymore, was it you guys asking me that? No? Oh, okay. Well, anyhow, one of my other classes they did, and I told them, it's because the higher up management people told us we had to take it out because they thought it was too theoretical and abstract and they wanted us to be a bit more practical. They've just told us to bring it back in. So next year, we're going to have lighting subjects again. But anyhow, you missed out, but this is pretty much the sort of thing we'll be doing anyway. So, so luminous flux, again, lumens, is the units that it uses. But then how do you know what a lumen is? Well, I'll give you some baselines in a minute, but to understand it, a good way is to start with this other one, luminous intensity, because it's in candelas. So CD means candela. So how bright do you think a candela would be? Roughly. Exactly, that's it. A candela is a candle. And so it's an old imperial unit. And so lumens are just a metric candela. So it's roughly 10. So a lumen is roughly 10, or 10 lumens is roughly a candela, roughly. So think of it like that. So, so 1,000 lumens is roughly 100 candles, which is, from my experience, about the brightness of many light sources. Don't know why this keeps coming up with that message. That normally doesn't happen. What? Okay, there's something funny going on here. That shouldn't be such a difficult thing. Let's just... Revit programmers, if you're listening to me on this video, do your job properly. This is Joe. Oh, gosh, why can't they hire some people with a brain? Okay, so it's not even letting me type in. All I'm trying to do there is change that to 1,000. That's ridiculous that you can't. That's just a joke. Okay, I'm sorry, that's the software misbehaving. Okay, I'm going to get a different light. I think maybe it's that light that has the problem. Let's try this one. Because you've got to be able to adjust the lumens. There we go, that's working. Okay, so 1,000 lumens, again, is a good baseline to remember. And you don't want to go too much above or below that level. Yeah, yeah. So you can go, I mean, for a really dim LED light, you might go down to even 10 or 20 lumens. But for something that's going to really give you some sort of lighting onto other things, you'd need it to be at least in the hundreds. But then if you're going the other way, if you're going above 1,000, if you're getting into values of more than about 3,000 or 4,000, then your lights are probably too bright, and you probably should be looking at exposure to adjust your overall brightness instead. So 1,000 is a good baseline, and you do need to think in real world units, even though in the past you could just have an absolute lighting value and not worry too much about exposure. These days, because these programs use physical properties of light and scale and everything, you've got to put those things in. So very fast thing, because I want to give you some time to actually do some work. So we've looked at the brightness, the lumens, and the initial intensity, and then the final thing is the colour, which I think I've talked to you a little bit about before, whether it's cool or warm. I'm sure I remember talking to you about this before, but am I right? Do you remember looking at this before? Or not? You don't? Okay. So maybe it was a different class. All right. So have you dealt with the colour of light before? No? Okay. So all lights have this property. So again, when you select any light in Revit, and of course the same with 3ds Max, go to Edit Type in Revit, and then below the intensity, initial intensity, you've got initial colour. I wish they would take the initial out. Technically it's correct, but it's also confusing. So colour, really, is the way you should be thinking of it. So what you need to understand about the colour of light as it comes from a light source, in other words, an electrical thing that we use to emit light, or the sun as well as another light source, of course, that works in the same way. What sort of colours do you think you can get that light to be? Can it be any colour? So can you have the sun giving you purple light, or pink light, or green light? So? I suppose in theory it's possible, but have you ever seen that? So what sort of colours do you get from the sun, from sunlight? Warm, that's right. So you can get warm, so you can get orange and red, and you can go the other way in noon. White definitely, yeah, so that's neutral. But then going past that, blues, that's right. So the range is generally from blue to orange. And it's all to do with the temperature. It's going beyond the normal temperatures that we deal with, and that's why it's a bit hard to relate to. But it's important that you understand it, because all lights have this range. And so when you start with a low temperature, so let's go for one of these sodium lights, which have a very low colour temperature. 1800 is extremely low. So it's very orange. But you'll see that in real life, because when the sun passes through the atmosphere in, at the end of the day, it's sunset and then sunrise, same thing, you get that warm orange light. And then incandescent lights, some fluorescent lights, but also some LED lights have quite warm light as well. But fluorescent lights, you probably think when I said warm, they don't really get that warm. There is one though, that's a warm fluorescent. But normally fluorescent lights are associated with cool light, because most of them are a higher temperature than that. So this is what's called a cool white fluorescent, but that's still not that cool because it's orange. So if we go up to one that I know is even higher, like xenon, you can see that's 6,000, which is quite a cool light. And you can see it's getting a blue tinge to it, if you can see that with your eyes. I know on the screen it'll look fairly white, but trust me, that's a fairly cool one. And if we go even higher, I'm just going to go to custom and then make that temperature go up to say about 8,000. And you can see there, we can really start to see that blue tinge going over that whole render. So again, that's the range. You can't get all the colours, and there are technical reasons for that. So if you want neutral, again, there is a bit of a range with neutral. It's got here D50, which is 5,000, up to D65, which is 6,500. So that's normally the range that neutral is considered to be. So technically it's not pure white at 5,000, you can see it's still orange. When we go up to D65, that's more white but a bit blue. So in between, I think it's about a bit under 6,000, you'll get something close to natural white. So there we are. That's still a little bit warm on the screen, but that is, again, fairly neutral. And so again, that's an important property of light, that you can set the colour temperature. And the way I always think of it is, again, the old incandescents and even some of these industrial lights like metal halide and the sodium things and the phosphor are fairly warm usually. And then some fluorescence, but then also, you know, these other sort of industrial ones like xenon get fairly cool. And a lot of the newer lights, so a lot of the new LEDs and all those dichroic things, again, they can be fairly cool. So they don't have to be, and that's something you decide when you're designing your lighting, whether you have warm or cool light, or you mix them, or you go more for neutral. And that's actually why what I was telling you about us wanting us to take lighting subjects out of this course originally for a while, because it gets really, really technical. And I've dealt with lighting engineers and lighting specialists for many years, and they've mostly studied at uni for several years to get a bit of an idea, but even then they don't really understand it until they've then worked with these lights physically in real life for many years after that. And the way they learn it is by turning the lights on and seeing how they work in a space and moving them around with different fittings and things like that. It's a really difficult thing to understand just by looking at the theory. But again, you've got to know these basic concepts. So you've got colour. But I'm sure you've all seen that there are other coloured lights. So how do you think you get different colours if you don't set it with the temperature? What do you do to get, say, a purple or a green light? Exactly, filters. That's right. Stick a gel over the top, or a bit of glass that's coloured over the top. So that's normally the way you do it. But I was going to tell you something that's going to contradict everything I've just said, which is that if you know the term limelight, have you ever heard from theatre? Do you know where that term comes from? So it's, yeah? Oh. Yeah. Yeah, well, it's one of these things I always tell you, because it was from a real person who made. Yeah. Yeah. Oh, yeah, that's gels. Yeah, so that's right. So that's the filters, and you can put any colour. So that's how they do it now, and they actually do this green effect. So it's called a limelight because the original light was green. So the spotlights that they put to focus on someone on the stage had a green tinge to it, and that's why it was called the limelight. And so now, because that's sort of becoming ingrained, they often will put a green filter on that spotlight because people expect this sort of green effect. They don't really notice it, but they expect it psychologically. And so they're simulating this effect that used to be there naturally, because one of the early lights before they had electricity, the spotlights were made with this chemical reaction, and that chemical reaction produced light that had a slightly green tinge to it. So that's where that term comes from. So you had green light coming from the light source itself, but that was a chemical source to the light. It wasn't with electricity. So that's one way of getting a coloured light. If you want to make this, really dangerous, burning combination of chemicals that lit up and worked for spotlights back in the 19th century, I think it was. But again, these days, of course, we do all the lights with electricity, and so, again, gels. In other words, coloured filters that go over the lights. So maybe I'll just try one so you can see it. Let's get a colour that's very difficult to get any other way, pink or something like that, magenta. And, of course, we're going to see some coloured light. So there's my coloured light there. Okay, so once you understand those things, you should be able to get any lighting effect that you want, and also be able to work with particularly Revit families more comfortably, because what you'll see is that a lot of the lights that you can download, say from good old, Revit City, they're good, a lot of them, but they won't always be set up for rendering, because not everyone who uses Revit needs to do rendering. So if you've done that, have any of you tried downloading lights from here? Maybe not. And same from other places where you can get light families. So where's lighting? What are these? Specialty. No. Here we go. Is it this one? Yeah, I don't want to show. Here, there we go. So there's a light fixture that you can download. Yeah, ugly, but look, it should work, and they normally are set up to actually give you some light when you render.
So how do you know if that's set up?
Oh, you have to download it and then try it out. That's the only way. But then what you'll often find is that they maybe will put the light fixture or the light emitter maybe inside an object. And so if you render and you realise it's not giving you any light, then you can check to see if that yellow emitter is inside something that's solid, and then you can just move it, and that should make your lights work. And also, it could have those settings not right, so the intensity or the colour might be something you just. Of course, that's the other good trick. So so you might just want this for the fitting, and then that's a good trick. Stick a studio light underneath it, and turn that studio light into a spot distribution, or whatever you want, and it's going to work perfectly. That's a good approach. Yeah, I do that all the time. So that's a good idea. And then the final thing I'll tell you, or tip I'll give you about using downloaded lights, is that if you've noticed when I was looking at those light families, it only gives you the setting for one light. So that's the limitation with Revit. You can only have one light fixture in a light family. So if you see a light family in Revit, and you'll find these that have, say, track lighting with 3 or 4 lights on a track, they'll have that as families that you can download. But you should know then that because you've only got the settings for one light in a family, it's not possible for that track light with 4 lights in it to ever render with all 4 of those lights giving you light. It's just not technically possible with Revit. So the better way, the way I do track lighting, instead of trying to do it with one family, I'll have a light family that is my, the thing that's on the track, and I'll copy that and have 4 of them, and then I'll just model the track as a separate thing, instead of trying to do it as one family. So again, as long as you remember that limitation of Revit families, light families, only being able to have the settings for one light, then that should make it easier if you ever have to use track lighting, or even this one. So this light fitting would have 3 lights. But it's not possible for Revit to have all of those giving you light in your renders, unless you put 3 light families in, and then it would work.
So 3 light families, 3 times this?
So you might have this, and like you were saying, you could just use this for the fitting, and then you could stick 3 studio lights there to give you the actual light for your renders. And that's it. So that's good. So I know it's a bit of explanation to understand those things, but it should help you all. And so maybe to finish off, I'll just show you that that file that I've been working in, which I'll just go and open again. So there's my, let's ignore this thing. So there's my, my file that I was showing you before, and it's got the. So annoying, what they've done with display. So it's got the lights that I had earlier, and then just to remind you how to bring in the changes. So maybe I've got this studio light that I'm going to delete, and then I'll maybe just to get something different, I'll copy the furniture. Just so we've got a few things that you'll see clearly different. Okay, so I've made some changes. I'll save my file, and then to bring those changes into 3ds Max, under File, Export, FBX. So I've got to go and save it into the same folder I saved previously. So there, and that's the file I saved earlier, so I'm just going to save over that, and it's going to say, do I want to overwrite it? Yes, I do. Now into 3ds Max, I just need to go to the File menu, under Reference, and then go to Manage Links. So it's a bit like the option you have in InDesign and Illustrator. So here you go to the Files tab, make sure you've got that file selected and click Reload. And look, at first you can just leave all these options as they are, click OK. And there you can see it's brought the changes across. So that should be the process. Once you've set up that 3ds Max file, then you can just keep updating to bring the changes across from Revit. So I'm not sure if you've got any questions about that. You probably want to get on to doing some work and trying some things, but let me know if you've got any questions. Otherwise, I'll finish that one there.